Hey guys, so this is just the last part of what we have on page 17. You should have graphed this and gotten this weird U shape. And this actually has a specific name. But of course I lost my pen because I'm Michelle and I lose everything, right? Um, so it is a parabola, spelled like parabola. Okay, so it is called a parabola. So any graph, any equation that has an x squared in it like this, it's going to end up being this U shape. All right, so things that we should know is that they are U shaped. It has a vertex, which is either the highest or lowest point. Because a parabola can open up or down. Okay, so if I have my graph, I can have a parabola that opens down, and in which case this right here would be the vertex, or it can open up like this one, in which case this lowest point would be the vertex. So it's like that very bottom of the U or the top, depending on which way. Oops, you can't see that. How about that? Okay, so depending on which way it's opening, it's either the highest or the lowest point. Okay, we're really not going to do much with parabolas, but it's important that you guys at least have seen this before you get to high school and everything. Okay, so that's a parabola. It's U-shaped. It has a vertex at either the highest or lowest point, and it can open up or down. All right, and then the last part for today, we're going to go ahead and write an equation. Now that we've been practicing with equations a little bit, we're going to go to page 37. Okay, so this is page 37, and I just want to talk about this John's Giant Redwood. Okay, so if you guys remember, like 2 days ago or something like that, a couple days ago, you guys started talking about John's Giant Redwood tree, which starts on page 4 of your workbook. Right, this thing, the John's Giant Redwood that we did. So now we're going to actually write an equation for that relationship. So they just copied the table back over here that we had on page, whatever that was, page 4, page 5. So now we're going to try and find a rule for the height of the tree. Now remember, each year this tree was growing 4 feet, right? So we were repeatedly adding 4. That tells me that I know I need some kind of a times 4 in my equation. Okay, so I'm going to have some kind of a 4 times x, right? Because the year after planting is x and my height is y. So I know that this number is being multiplied by 4, but let's see what else I need to do to be able to get to my y. So I have 3 for the years after planting. If I multiply 3 times 4, I know that that's 12. But then I have to get from 3 to 7, or I'm sorry, from 12 to 17. I know that that's plus 5, but let's see if the same thing is true over here. So if I do 4 times 4, I know that that's 16, and then plus 5 gets me up to 21. So I know that to find y, I need to multiply my number of years times 4 and then add 5. So if we think about this, the x in this equation really means the number of years since planting, and y is the height of the tree. And we'll get into this a little bit more later, but this 5, okay, so this plus 5 is actually our starting point. So at year 0, it was 5, and that's how we can figure out that we're starting with a plus 5. So if John wants to know how tall the tree will be when it is 35 years after planting, I can use this equation that we discovered to figure that out, right? So this is telling me the height of the tree is equal to 4 times the number of years plus 5. So if my number of years is 35, I know that the total height is going to be equal to 4 feet per year. So 4 feet times 35 years plus that 5 feet that it was when it was first planted. So 4 times 35 is 140. Okay, 140 plus 5 gives me a total height of 145. Okay, so after 35 years, the tree will be 145 feet tall. And it's important that you say your answer in the context of the problem so that we know what you're talking about, right? So y equals 145, but what does that mean? Okay, well, that means that after 35 years, the tree will be 145 feet tall. Okay, so the tallest tree in the world in Montgomery Woods State, blah, 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 in Montgomery Woods State Reserve in California is 367 feet high. John wants to know how long it would take for his tree to get that tall if it keeps growing at the same rate. Write and solve an equation you could use to answer John's question. Be sure to check your solution. Okay, so we're still going to use this same y equals 4x plus 5, but now we need to think about what information we're actually being asked to find. So I know that I'm looking for a tree that is 367 feet high. I know that my height is also my y. So in this case, I know y, but I want to know how long it would take. So the number of years, and I know that that is x. So instead of substituting this number in for x in my equation, I'm going to substitute it for y and then try and solve for x. So I have 367 equals 4x plus 5. Now, if we think about our solving equations, remember, I don't want to try and get rid of that 367. I want to try and get rid of that plus 5 because I want this x all by itself. So if I take away 5 from both sides, I now have 362 is equal to 4x. So to undo this multiplication, I'm going to have to divide both sides by 4. Okay, so 362 divided by 4 gives me 90.5. Okay, and since that's x, that tells me that it will take 90.5 years for the tree to be 367 feet tall.